In calculating the definite integrals 3x minus 5, first of all, if you have the integral of dx, you have invisible function 1 dx, which is x plus c, constant of integration. So if I ask you to calculate the definite integral a to b of dx, you're going to say that it becomes b minus a from the fundamental theorem of calculus. If you have the integral of x dx, this is going to be x to power 2 divided by 2 plus c, and in general, if you have the definite integral a to b of x dx, it becomes b squared minus a squared divided by 2. So from indefinite integral to definite integral. And in general, if you have the integral of x to power n dx, this guy is x to power n plus 1 divided by n plus 1 plus c, and indefinite form from a to b, x to the n dx is b to power n plus 1 minus a to power n plus 1 divided by n plus 1. So these are the formulas that we're going to follow when it comes to the integral using power functions. So in calculating this integral, you can divide this integral into two separate integrals. You can write it as the integral from -2 to 4 of 3x dx minus the integral of 5 dx, and x ranges between -2 to 4. For the first integral, this can be written as 3 times the integral -2 to 4 of x dx minus 5, the integral of dx, x ranges between -2 to 4. And remember that if you have the integral of a dx or k dx, and k is just a coefficient or a number, you can write it in front of the integral. You always have that choice. That's how I took this 5 and wrote it outside the integral, the same as 3, which is just the coefficient. I write it in front of the integral. Sometimes it makes calculation a little bit easier for us. Now, this can be written as 3, but the integral of x, this x has invisible exponent 1, so it becomes x squared divided by 2, but following the definite form, x squared divided by 2, it ranges between -2 to 4, minus 5, and the integral of dx, as you know, it is x plus c, but if you just take the x itself in definite form, it becomes the integral, definite integral, and you have to just add the boundaries here. So this becomes 3 times, you get 16 minus -2 to power 2 divided by 2 minus 5, substitute 4, minus -2 goes in parentheses. Remember that you have a minus sign in between these, and whatever that number is, a, that negative sign might affect that value as well. So this becomes 3 times 16 minus 4 divided by 2 minus 5 times 4 plus 2. This is the integral of 3 times, here you have 12 divided by 2 minus 5 times 6 Or if you simplify this guy, you get 6 times 3, 18 minus 30, which becomes negative 12. So this is the calculation of this definite integral. So if someone says, hey, does it represent area? Not necessarily, because we don't have negative area. We just did the calculation of this integral, and it might have other applications. So next question, we're interested in finding the integral of x to power negative 2 when x ranges between 1 to 2. The formula that we're going to use are power rule formulas. So let us identify n. N is the exponent of your x, which is, in this case, negative 2. So this integral can be written as x to power negative 2 plus 1 divided by negative 2 plus 1, as your x ranges between 1 to 2. This in turn is x to power negative 1 divided by negative 1, and you have your range 1 to 2. In many cases, in many examples in the book, we're going to see, okay, the integral of x to power negative 2 dx is negative 1 over x plus constant of integration. These are the algebra behind them. So this is negative 1 over x, and you have your range between 1 to 2. Substitute 2 first, negative 1 divided by 2, minus, it has a subtraction in between everybody. So we have to use a parenthesis, negative 1 divided by 1. Perfect. So you have negative a half plus 1, or just 1 divided by 2. So again, in the books, in the examples, sometimes they just write this guy without adding more context. They say here the integral of x to power negative 2 dx is negative 1 divided by x plus c. So when you add the lower bound and the upper bound, a to b, it is basically, so you have negative 1 divided by b minus negative 1 divided by a, and it becomes negative 1 over b plus 1 over a. So in many books or shortcuts, they just write this as 1 over a minus 1 over b. But this is what we need, what we look for when we are doing the calculation for these types of integrals.